To start off this lesson, here is your anti-set. You should try to do this by yourself, so pause the video and complete the anti-set in your notes, and then unpause when you're ready to see the answer worked out. So to find dy dx, we need to find dx dt, and we need to find dy dt. Because dy dx is just going to be dy dt divided by dx dt. If you simplify those fractions, the dt's will cancel and you'll just be left with dy dx, which will be the slope. So we need the change of x with respect to time, change of y with respect to time, and then we're going to divide those two changes, and that'll give us our change in rise over our change in run. So right here we have a little chain rule going on. We know the derivative of negative sine is negative cosine. And I should write this like this, negative cosine of 5t. We leave the inside alone, but then the chain rule dictates that we should multiply by the derivative of the inside function now. Derivative of 5t is just 5. So we get negative 5 cosine 5t. Now to do dy dt, it's going to be helpful to write 1 over t squared as t to the negative 2, because then we can easily see what our power rule is going to give us. It's going to give us negative 2 times t. We multiplied by the exponent, and now we're going to subtract 1 from the exponent. So now we can rewrite this as negative 2 over t cubed. So we have dy dt, we have dx dt, and now we just need to divide them. So we get negative 2 over t cubed divided by negative 5 cosine 5t. So we have a fraction in our numerator. We technically have a fraction in our denominator too. We can put this over 1. So if you really wanted to simplify this, you could now write it as negative 2 over t cubed and then multiply by the reciprocal of the denominator, which is 1 over negative 5 cosine 5t. Those two negatives are going to cancel positive, and so then we are just left with 2 over t cubed times 5 cosine 5t. That is our final dy dx. Great review from last lesson. So more review is how we get a point moving in a circle clockwise versus counterclockwise. So recall that if you have cosine as x and sine as y, well, cosine, its outputs start at 1 and then approach 0 as we approach pi over 2. So it goes from 1 to 0, 1 to 0. Now sine goes from 0 to 1. So x goes from 1 to 0, sine goes from 0 to 1. That combines to this point moving counterclockwise. Okay, so it's going to keep following this path. Whereas if sine is x and cosine is y, well, sine goes from 0 to 1. So x is going to go from 0 to 1, 0 to 1. Cosine goes from 1 to 0. So y is going to go from 1 to 0. So x goes from 0 to 1, y goes from 1 to 0. That combines to the point moving like this, which is going to take it in a clockwise direction. So if sine is first, clockwise. If cosine is first, counterclockwise. So now we're going to get into more complex movements. So we're going to take a fixed point on a wheel. You can picture it as being like a bike light, right? A bike light that is attached to the bottom of the wheel. And the wheel is going to be moving, and the light's going to move with it. And I'm sure that you know that if I was presenting a real PowerPoint, of course I would have a good animation of this wheel moving. But we can just look at the progression here. As this wheel rotates, that light is going to follow a certain path, and our goal is to model the path of the light parametrically. So that is our goal of the first part of this lesson. So open up a new tab, or if you have access to another device, you could use that instead, and just get Desmos pulled up. And your first task is to try to just graph a circle parametrically. I just need to see a circle. And once you have your circle, try to shift it up so that the bottom of the circle is resting on the x-axis. So you may start with a circle that looks like this, and I want you to mess with it so that it looks like this. So in Desmos, you're going to have something of t, comma, something of t. and then you should let t go from 0 to 2 pi. So there's going to be some kind of function of t here, some kind of function of t here. Let t go from 0 to 2 pi. First try to get a circle, and then try to get a circle that's shifted up. So pause and try to do that, and then unpause when you're ready to check. So cosine t sine t, as we know, would give us a circle. And then if you do, take your y value and you add 1, that's going to make it so the circle's center is shifted up 1. So now you have a circle that is resting on the x-axis like this. So then now what I want you to do in cell 2 is type in cosine A sine A plus 1 and add the slider, because what that's going to do is it's going to allow us to see what happens as we let our t value change, as we let that input change. So just add a slider and hit play and see what happens. So then stop and think, if we ultimately want this point to be a fixed point that's moving on a wheel, what issue do you notice, or what issues do you notice? So first of all, it's starting here, and in this problem we're going to have it start on the ground. And second of all, it's going the wrong way, because if the wheel is going like this, that means the point is moving clockwise. But if you hit play on this, that point is going to be moving counterclockwise. So think back to that review problem we did after the antiset, and think about how you can fix this. And again, mess with Desmos, hit pause on the video, and see if you can find a way to make the point go clockwise, and then also try to get the point resting right there. So if we switch cosine and sine, that is going to do the trick in terms of making sure that it's now going the right way. But now we're not quite there yet, because now the point's up here, and I want the point to start down here. So the last step is we're just going to reflect this circle, so multiply by a negative so that it reflects down here. So we multiply both x and y by a negative, and then now the point is down here, and then now the point should correctly be moving clockwise as the wheel goes. Okay, so now we don't have a moving wheel right now. We just have a wheel that's going around stationary right now. So which component will we need to change, x or y, if we want the wheel to move? So just look how that point is going. It's going horizontally, right? So that means that we should add something to our x value, because that's going to allow our x value to change, and then over time, and cause the wheel to move. So again, what did I just say? I want the x value to change over time. So if we just make the x value time, okay, if we make it our a value, which is our time moving on, okay, that's going to allow us to have a point that is now moving. So if you hit play on this, you should have a circle that's moving, and you should have a point that's going around it as it moves. So you can play and mess with that. Now we need it to be a, because we need that to be changing as time goes on. That's going to cause this wheel to move, and it's going to cause the point to move. Okay, so I'm actually going to pause here and split up the lecture into 2. So we're going to do this with vectors next. We just kind of did this by trial and error and messing around, but now I'm going to show you how to come up with this using vector reasoning. So that's going to be the next part of this lecture.